Hello viewers, in today's class we are going to discuss one important definite integral in which the denominator is a function of sine square x and cos square x, right? So here uh, in order to solve this definite integral, we have to make use of a special strategy, and the strategy is that we have to divide the numerator and denominator by cos square x, right? So we'll divide the numerator and denominator by cos square x. So when we divide the numerator and denominator by cos square x, we'll get the integral 0 to pi by 2. Here we have 1 over cos square x, and in the denominator we have 4 sine square x divided by cos square x plus 5 cos square x divided by cos square x, right? Okay, now here we can simplify it. 1 over cos square x is secant square x, and here we have 4 tan square x, and here we have cos square x and cos square x get cancelled, and we are left with 5, right? So here we have divided the numerator and denominator by cos square x to get the sec square x in the numerator, because the derivative of tan x is secant square x, right? So now here we'll substitute t is equal to tan x, right? Because the derivative of tan x, it exists in the numerator. So therefore dt over dx is equal to secant square x. So this implies dt is equal to sec square x dx, right? And here we see that x varies from 0 to pi by 2. So let us change the limits accordingly, right? So when x is equal to 0, then the value of t is tan 0, that is equal to 0, right? And when x is pi by 2, then t is tan pi over 2, that is not defined, which is equal to infinity, right? So now we can change this integral I in terms of t. So we have 0 to infinity, and for this sec square dx we have dt. So here we have dt, and in the denominator we have 4 t square plus 5, right? Now we can take this 4 common, so we have 1 over 4 and dt over t square plus 5 over 4, right? Now we can express this denominator as dt over t square plus root 5 over 2 square, because root 5 square is 5 and 2 square is 4, right? So here we have a known integral, because we know that integral of dx over x square plus a square is equal to 1 over a tan inverse x over a, right? So this is the standard result, right? So now we have to apply this result to this form, and we have I is equal to 1 over 4, and for a we have root 5 over 2, and for x we have t. So the integral is 1 over a, that is root 5 over 2, and tan inverse t over root 5 over 2, right? So here this 4 get cancelled here, 2 to the 4, so we have 1 over 2 root 5 tan inverse. The limits are from 0 to infinity, right? So here we have tan inverse 2t over root 5, and the limits are from 0 to infinity. Now we can substitute the limits and we'll take the difference. So now we have taking 1 over 2 root 5 outside, we have tan inverse for t is equal to infinity, we have here infinity minus tan inverse 0, right? So t equal to 0 gives us 0 here, and this is 1 over 2 root 5, and tan inverse infinity is pi over 2, and tan inverse 0 is 0, right? So now we have pi over 4 root 5, 2 to the 4, so 4 root 5. So viewers, the value of this definite integral is pi over 4 root 5.